Good morning. We're presenting our project on real-time and batch access log processing. So this project demonstrates a scalable pipeline for processing web server logs using Kafka, Cassandra, and Spark Streaming. So let me quickly walk you through the architecture. So we have the first layer, which has browsers and JMeter that generates traffic. In the second layer, we have Nginx load balancer that distributes for requests to web servers. We have the third layer that has four Nginx web servers, which serve five product pages. And for the fourth layer, we have FileBeat that ships logs to Kafka Broker or raw log topic. The fifth layer, we have two consumers in fan-out pattern. The first consumer, which is Cassandra. So the first consumer writes raw logs to Cassandra, and the second one is Spark. It does real-time aggregation. And here we have a batch script that runs daily at 8 p.m. So this architecture follows the Unix philosophy from chapter 10 of our textbook, immutable inputs, composable tools, and clear data flow. So the system produces the top 3 visited products every 5 minutes in real time and runs batch processing daily. Both N and P are configurable parameters. And now we will move on to the infrastructure step. Okay, so now we will show you our containerized infrastructure. So here we first run our script, which is start all, that runs all the services one after the other. And here, as we can see, we have 9 Docker containers running. First, we have the Zookeeper, which is the Kafka coordination. We have the Kafka, which is the message broker. We also have Cassandra, which is the NoSQL database, the Nginx, which is the load balancer, and 4 Nginx web servers, and the FileBeat for the log shipping. So all of these are configured using Docker Compose for easy deployment. And here we will show you the file of the Docker Compose. So as we can see here, we have at the top, this is our file. We have the Zookeeper here, which is to coordinate the Kafka, and it handles broker, metadata, and health. We have here the Kafka broker, which is our streaming layer. And we have Cassandra, which is the storage layer where we process the log analytics. Here the Nginx load balancer that acts as a load balancer, distributing the traffic across multiple web servers. And here we have the 4 web servers. These are identical backend web servers where each one writes access logs to disk, so FileBeat can collect them. And here, lastly, we have the FileBeat that read the logs from all web servers and streams them into Kafka. And here we have at the bottom, we define and share a shared network and volumes to persist data and logs. And here are our key configurations. So here the Nginx web servers use the JSON log format. This is important for Kafka integration. Each log entry is structured the JSON object with timestamp, client IP, request URI, and status. And here we have the FileBeat, our file, which reads these JSON logs and ships them to Kafka's raw log topic with the gzip compression. And now we will move to the Cassandra schema. So here we have 2 wide column tables. We have the log table and the results. To see it in more detail, here. So here we have the log table that stores raw logs partitioned by date for efficient batch processing. And below we have the results table that stores aggregated data from both real-time and batch processing. So now for the JMeter setup. So I will demonstrate our load testing with the Apache JMeter. So here in the thread group, we have configured 100 concurrent users to stress test the system. So to simulate realistic traffic patterns, we use the CSV dataset config element. So here we put our CSV, which is the product CSV. Here we can see the distribution. So for product 1, we have 50%. Product 2, we have 25%. Product 3, we have 50%. And for product 4, 8%. And for product 5, we have 2%. So this allows each virtual user to pull a random product URL from the file and sends it to our Nginx load balancer. So now we can start the test either here by clicking on start, or we can do it from the terminal. So in this example, we will run it from the terminal. Okay, so now we will run our test in the terminal using this command. And at the same time we will run our consumer so that it can receive the messages. So here we can see that it is processing the images that were sent from here, which are about 10,000. And here you can see the 10,000 requests, as well as here we have 983 requests per second and also 0 errors. So here it will take some time, so we will go directly to the results. Also, it is now still processing the messages, and we can at the same time check if Cassandra, like the data reaches Cassandra. So here, this was the previous count, and here the current one, and it keeps updating until all the messages are processed. So here we will repeat another time. So here we can see an increase as the log is processing the messages. So now we can see that it has processed all the 10,000 messages, and this was the amount previously. And now we will run the command to check if the data is received, and we can see that the count has increased at about 10,000. So now to have more information, we will create a dashboard using the gmeter dashboard to have more information about what happened. Here we will generate the report. So here it is generating. So now it is generated. We'll refresh. Here we have the dashboard report. And here we can see the information of our test that we performed. So here we have the total 10,000 samples, the throughput, the response times. Here the errors, we have 0 errors. And here we have the charts, response over time, and so on.